Hey friends, in this video I'd like to try the new ORCA2 model which was released by Microsoft, and it's open source and we can use it without any OpenAI API key. We just run it on our own local hardware. So let's get started. For this I also used LangChain, so I combined the large language model with LangChain, and if you want to do you can do it yourself or ask in the comments and I can create another video. But in this case I also imported Streamlit and Chainlit here, because I used them as web front ends, so to have a nice GUI. But in this video, I just want to stick to the command line, which in this case might be a little bit simpler. So for that, I just go in here and say from LangChain chains, I import the LLM chain. That's the simplest chain you can have. Actually, it only needs two things. It needs a prompt template, and then it needs also the large language model. So I also imported the prompt template. Be aware if you are on the later versions of LangChain that please import it from prompts and not import the prompt template from LangChain directly. This is deprecated and will not work in the future anymore, just to mention this. So the Hugging Face Hub, you can use it, but in our case, we don't need to download it because I already downloaded the model weights from Hugging Face. You can do this. For instance, the bloke releases a lot of, model weights there, which you can download, and I can also show this to you in a minute, but actually it's specified here already, ORCA2 7 billion, that's the one I use. But about the imports, I also use Feis here as my vector store. You can also use ChromaDB or Pinecone or any other kind of vector store. There are certain ones which are free and also ones which you have to pay for, but it's up to you. Just to mention, Feis is loading the data in memory, okay? We need to be aware of this. But we can also store the vector, which we created, or the vector store, to local disk. That's also possible with Feis, simply by calling, I think it's load and save model. I think load model and save model should be the case, but you can also look it up in documentation. So for the loaders, I'm using a text loader because the data which I want to read is actually here write good prompt txt. It's a text file, so you can use the text loader. If you have PDF files, use PDF, PyPDF loader. If you have data in a directory, you can use directory loader and giving a loader class, so various options out there. So then I'm using C transformers in order to load the data. So in this case, the ORCA2 model, and this is also available from LangChain directly. So then we load the data in here. This is my data itself, so write to prompt, which is in this specific path. We load it using .load method, and then we also use here Hugging Face embeddings, so we use open source embeddings instead of using OpenAI embeddings. So again, then it just means that we can also use something which is we don't have to pay for, just in case you do not have, for instance, an OpenAI API key. So then we split the data using recursive character text splitter. We specify chunk size and a chunk overlap. You can play around with this specific values if you want to have some overlap. Most often I use it, actually a good idea, but it's something you need to have to tweak with your own data to see what kind of numbers make sense here. We split the documents, which is coming here from the loader, and then we store it in docs, which just means that now we have a list with chunk size of text. And then we actually call, here, the class, the Feis class, and create our vector store from the documents, so the split documents with the embeddings, which are open source here. We have the vector store, and now we instantiate our LLM, which C transformers with the model. This specific file is around 4 GB, which is quite small, actually. Which is great, and I just downloaded it from Hugging Face website. So you can go there and you can download it for free. So you specify the type, which is ORCA, because we use an ORCA model here. If you use Llama, you need to specify type Llama. If you use, for instance, Mistral, you should specify type Mistral, and so on. So then for the configuration in here, I'm using 3 options here, which is max new tokens, which is referring to the amount of tokens which the answer the large language model gives us should be a maximum of. So 200 is, I think it's maybe one token is 0.8 or 0.7 words, so more or less the rule of thumb. So you can play around with this. Of course, if you want to have longer text, specify a higher number here. The temperature itself, and then also the GPU layers. In this case, I have NVIDIA GPU, so I can use specify GPU layers here. If you don't have this, just comment this out. And then the retriever itself is, in this case, the vector store, which you're going to use. And then we specify here our template. The template here for ORCA model is like that. So 3 hashes instruction, then the query, and then 3 hashes response, and then response. In this case, the query itself is the input parameter of the template, so that's why I specified here. And then we just run the chain, and in this we instantiate the chain, here we run the chain, here 3 traits of a great prompt for a large language model, and then we print the results. And that's it. And now if I go in here and just run this, for instance here, let's go there and say, in this case, Python, and then local orca.py. So py, like this. Let me run this, and then let's just see the result. So now it's loading, actually, in here, also Vice, it's great here, Vice, it just takes a little bit of time, and let me just move this up a little bit. Now we can see here the instruction itself, and now we have here our response. And yeah, that's it. I mean, you've seen that it was quite fast, actually, giving us answers here, which is actually amazing. And also, I mean, at least because it's open source, and it's still that fast, and gives us here the proper answers to my question here. And basically, yeah, that's it. So this is how you can use the ORCA2 model, and I encourage you to try it out, because from my point of view, what I've tried so far, it's one of the best models I've seen, and it's that small, well, for a large language model, and the performance is really great. So hopefully the open source community is, well, keeping up with the pace and creating even better models in the future, so we can have actually our own large language model, which of course we can train then without any GPT, for instance. So really completely open source, which would be really interesting. So that's it for this video. Hopefully you enjoyed it. If so, please give this video a like. Also, please subscribe to the channel. Thanks a lot for that. If you have some questions, let me know. Otherwise, take care and hopefully see you in the next video. Until then, best guys.